Hi, okay, so today we're going to talk about pure substances and determining their empirical and molecular formulas. So, pure substance is made up of one element, all of the same element, or, all of the parts have the same chemical properties. So, aluminum or gold. Pure substance can be a compound as well, where all of the molecules have the same ratio of elements. They can be ionic substances or molecular. There is only one type of substance that is present. So we have salt and we have water as our examples. So we have two types of chemical formulas. The first is the empirical formula. It gives us the simplest whole number ratio of atoms in a compound. And the next is the molecular formula. That is the actual makeup of our molecule. So if we had C2H6, that is ethane. That is the molecular formula. The simplest whole number ratio would be CH3. That is the empirical formula. So the empirical formula is our simplest ratio. The molecular formula is what is actually in the molecule. So how do we determine the empirical formula? The first step is list the formulas from the question with their percentage. So we have sulfur is 32.65. We have oxygen, 65.3. I'm sorry, that should be percents right now. I'm jumping ahead of myself. And oxygen is 2.04%. I'm sorry, hydrogen. Okay, so we listed the formula and we assume that the sample is 100 grams. So that means our percentage can become grams. So we're just going to turn these to grams. So again, we have sulfur is 32.65 grams. We have oxygen at 65.3 grams. And we have hydrogen at 2.04 grams. So now we need to convert the grams to moles by dividing by the molar mass. So we know sulfur has a molar mass of 32. So 1 gram divided by 32 grams. And this is going to equal 1.02. Hydrogen has a molar mass of 1 gram. So this is going to be 2 moles, 2.04 moles. And 65 65.3 grams of oxygen. We know that 1 mole of oxygen is 16 grams. And so this is going to equal 4.08 moles. Now when we look at these numbers, these are all close to whole numbers, 0.0 less than 0.1 or greater than 0.9. So they can be rounded up or down to the nearest whole number. So we have 1 mole here. We have 2 moles here. and we have 4 moles here. So we need to find which one is the smallest. So it's 1 mole. And we divide all 3 by 1 mole. And so we have S equals 1, H equals 2, and O equals 4. So our empirical formula is H2SO4. These are the steps that we just did. So determine the element with the lowest number of moles and divide them all by that number. These numbers become your subscripts. So what if my mole ratios are not whole numbers? So let's look at this one, and this one's a little more complicated to set up, but that's okay. So we have magnesium, (0.273 grams) plus nitrogen, but we don't know how many grams of nitrogen are there. Yields 0.378 grams of MgN, I believe. Okay, so the law of conservation of mass, if I start with whatever mass I start with, I have to end with the same mass. So 0.273 plus N2 is going to yield 0.378. So N2 is going to yield 0.378 minus 0.273. So our mass of N2 is going to equal 0.105. So now we need to change those percentage to percentages so that we can get a nice even number sample. So we have Mg and we have N, and we said Mg had a mass of 2.73. We said nitrogen had a mass of 0.105. So to get the percentages, 0.273. So to get our percentage, we divide by the whole, which was our total. So divide it by 378, divided by 378. So 273 by 3, let's see, 0.273 divided by 378. 0.273 0.378 is 0.72% or 70.72 times 100%. Is 72%. And for the nitrogen, 105. 0.105 divided by 0.378 is 0.28. Point 0.28 times 100% is 28%. Okay, we said the magnesium was 72 grams, and we said the nitrogen was 28 grams. So we need to convert those to moles. Magnesium has a molar mass of 24 grams. So that is 3 moles. Nitrogen has a molar mass of 14 grams. This is 2 moles. So the next step is that we divide both by the smallest, so 2 is the smallest. So we have divided by 2, divided by 2 equals 1. And this one equals 1.5. So that is not close to being able to round. We need to be within a tenth to be able to round. So 0.9 and up, or 0.1 and lower. So to get this to a whole number, we need to multiply this times 2. And if I multiply that times 2, I need to multiply the rest of them times 2. This is 3. And this is 2. So it becomes Mg3 N2. And that is the empirical formula. So if we wanted to find out the molecular formula, and we know the empirical formula, then we just double check the molar mass. If we look at this one, if we're looking at, this is our empirical formula, CH2O. Well, we know carbon has a mass of 12, hydrogen has a mass of 1, and there's 2 of them, and then oxygen has a molar mass of 16. So that equals 30. So the empirical formula has a molar mass of 30 grams. So now to convert, we said that our given molecule is 180 grams per mole. So we take 180, divide it by 30, is equal to 6. So that means we need to multiply everything times 6. So we come up with a ratio of 6, 12, 6. And so when we put that into our empirical formula, C6H12O6, also known as glucose. But so the CH2O will have several, for an empirical formula, there can be several molecules that have the same empirical formula. When we did ethane earlier, I believe methane has the same, so does butane. It's just how long is the chain.